Okay, this lesson we have molecular shapes and intermolecular forces. We'll just go over some stuff on this. As always, I typically don't answer the questions unless I feel that it is beneficial for your tutorial or lesson. And usually I let you do the videos and stuff like that on your own. So let's briefly talk about molecular shapes. Pretty interesting. This will go over like covalent bonding and stuff. I also have a few mini lessons on covalent bonding. So if it is in fact confusing, I recommend you look at that instead. So let's skip this covalent bonding and molecular structure. Let's see, this is an interactive model. This shows you the molecule. So, okay, here's our molecule. Here's, let's say this is water, for an example, H2O. So H2O. Okay. And then let's go to the next part. Yep. And look at that. I was right. It was water. So we have 2H, 1 oxygen. So this is a water molecule, for an example. In a covalent bond, a bond holding two atoms together as a result of their mutual attraction for a pair of electrons. Pretty interesting. All right, so orbitals. A region of a space around an atomic nucleus in which an electron is likely to be found. Okay, so now here we have, let's see, the hybrid orbitals, and we have just a couple examples. Here's methane. For an example, here's what it looks like. These are the atomic structures, like the compounds, of what it looks like together. So what the molecules or elements look like bonded together. That's kind of all this shows. Electron figuration is just like how many electrons in each shell. So like, and what's in the valence electron shell. So what's in the outermost shell. It just shows here's the electrons. Here's how many we have in each shell together. Lone pairs would be like a pair of valence electrons that's not shared by anything, that's just kind of by itself type thing. And this is showing again how things are shared together. And look, we have the symbol pi here and sigma. And look, algebra's coming into chemistry again. Just think they all kind of overlap each other. All right, so again, here's just some compounds, how they're together, they're bonded together. We have the electron dot model. So these also show like the electrons in the outermost shell. This is called a sigma bond and formed by an overlap of two hybrid orbitals. All right, so this will give you an interactive model, show some more examples for you. Here's ammonia and what the ammonia molecule looks like. All right, so let's go ahead and look at some more. Okay, so these questions, I will have you do these questions on your own. But here's just a quick table that shows some other molecules and what they look like. It shows orbitals, the number of atoms, and it shows like the type of structure. So this is linear, the first one, for an example, because it's a straight line. And as you can see why this one is called pyramid, it looks like a pyramid. Their names are based on kind of how they look too. Okay, so questions, I'll let you do these questions on your own. Polar and non-polar molecules. Think of like magnets. So a polar molecule, a molecule that has a positive side and a negative side, resulting in polar bonding. Okay, polar covalent bond, a covalent bond in which electrons are shared unevenly between atoms. So that means that, let's say hydrogen, there's only one electron that shares. Things are shared unevenly. There's not an even distribution between electrons. That's basically all it is saying. Periodic table. Okay, here's another example of the periodic table. We see like the different electric charges throughout. Okay, let's go to next. So this is the questions. I'll let you do these questions on your own. And let's see. We have a non-polar covalent bond. So that means that in this bond, there are electrons that they're shared evenly. So there's an even amount of electrons shared together. They're distributed evenly in this bond. Okay. So as you can see, like this would be an example, they're shared evenly together. These questions, I will have you do this on your own. Non-polar molecule. It does not have a positive side and a negative side. It doesn't have it. So nonpolar, you think polar, when you think of polar, think of like a magnet. The north and south side are positive versus negative side. Nonpolar doesn't have it. Okay, we'll let you do this on your own. Let's see, some more bonding happening going on. This one again, I'll let you do the questions on your own. There's a lot of questions on this one. And then I definitely recommend that you refer back to my little mini lesson on covalent bonds, because that will break down some things about covalent bonds. It tells you some cool characteristics about them as well. Okay. And this, it just shows you the different types of bonds and how it would work together. Okay, so questions, like I said, I'll have you do all of these questions on your own. And this just shows different molecules. And that's about it for this one. Just different types of covalent bonds and what goes on with a covalent bond. It is pretty interesting. But like I said, I refer back to the mini lesson on covalent bonds. It is a little bit less confusing and pretty straightforward for you. But I hope that clears a couple things up and hope you enjoyed.